Okay, my dear students, welcome back. In today's video, we will take a function and then we will write that function as a unit step function, and then we will find its Laplace transform. So this is what we are going to do today in this video. Now, let us take a question. Let us say that we have a function ft which is defined as 0 when t lies between 0 and 1. Then let us say this is equal to e power t when t lies between, suppose, 1 and 2. And then let us say that the function is equal to t whenever t is greater than 2. And what we want to do is that write this function ft as a unit step function and then find its Laplace transform. Okay, so this is our question which we are going to attack now. Now, first thing is how to write this function ft as a unit step function. So what we do, we start with this entry, that is 0. So u t minus 0 then in the second term we will have, you might have guessed by now that in the second term we will have u t minus 1, and then correctly you have guessed that yes, in the next step we will have u t minus 2. Now, what comes here, what comes here, and what comes here? Okay. Now, first term will contain the first value, that will be 0. Second term will contain this value minus the previous value. What it will give us? E to the power t minus 0, right? Or simply you can write it as e power t. And the third term, correctly you have guessed that it will contain this minus this. What we will get? In the third term we will have t minus e to the power t. This is the form of a this is the form of where we have written this function ft as a unit step function. Okay, so therefore correctly you have written this function ft as a unit step function. This first term will become 0, so no need to write this. The second term is e to the power t u t minus 1, and the other term we are getting is t minus e to the power t u t minus 2. So first part of the question we have done. What is the first part? Write ft as a unit step function, and we have successfully written it as a unit step function. Okay, done. Now let us go to the second part. After writing it as a unit step function, we will find its Laplace transform. Now, before I start this, we will quickly recap our second shift property. Which we will use here. Second shift property is that if you are finding Laplace transform of ft ut minus some a, this is actually given by e to the power minus as Laplace transform of f of t, we will replace by t plus a. Okay, this is the second shift property. Now let us try to use this. So this gives me, when I find the Laplace transform of ft, this will be Laplace transform of e power t u t minus 1 plus Laplace transform of t minus e power t u t minus 2. Now here we will try to apply the second shift property. Now see here, let us talk about this first term, this one. Now if you compare this term which I have put inside this green box with the second shift, if you see what is the form here, Laplace transform of ft. So my ft here is e to the power t, right? Then again go to the second shift, ut minus a. Here I have ut minus 1. So it means that my a is equal to 1, right? And my ft is actually the function e to the power t, right? So if I use the second shift property, this should be equal to e to the power minus as, that is a equal to 1. So it will be e to the power minus 1s. You can write it as e power minus s directly. Laplace transform of ft plus a. What is the meaning? In my function ft, which is e to the power t here, right? So in my function ft, I have to replace t by t plus 1, right? Because my a is equal to 1 here, isn't it? So what will I get? E to the power t. T I will replace by t plus a. That will be t plus 1 because my a is equal to 1. So it will become e to the power t plus 1. This is how we use the second shift property. Now, I am sure that all of you will write this second term very easily. So, in the second term, what is my ft? My ft is this t minus e to the power t. This is my ft. Second term is ut minus 2. So it means my a should be equal to 2, right? So using the second shift property, what will I get? E to the power minus as minus 2s Laplace transform of, in my function ft, I will replace t by t plus a. My a is equal to 2 here. So I will replace t by t plus 2. Wherever I see t, I will replace it by t plus 2. What will I get? T plus 2 minus e to the power t. So again, e to the power t. T I will replace by t plus 2. That's all. This is how we write second shift property. This is how we use the second shift property. Let us do some simplification and let us write the answer. So you are getting e to the power minus s Laplace transform of, this we can write it as e to the power t multiplied by e to the power 1, right? Plus e to the power minus 2s Laplace transform of t plus 2 minus e power t plus 2, that you can write it as e power t multiplied by e to the power 2, right? So here e to the power minus s, and here you have e to the power 1, which is a constant, right? So using the linearity property of Laplace transform, this constant you can keep it outside. So that will be e goes outside, e power 1, or simply we are writing e, okay? E goes outside, so Laplace transform of e to the power t. This is the first term, right? And second term will be e to the power minus 2s, and then you have Laplace transform of t plus Laplace transform of 2 minus Laplace transform of e to the power t multiplied by e power 2. And this gives us, you can combine these two, right? So this will become e to the power minus s plus 1 Laplace transform of e power t, okay? Plus e power minus 2s, and inside the bracket we have Laplace transform of t plus Laplace transform of 2 minus, again, e to the power 2 is just a constant, so you can keep it outside, right? So this will become e to the power 2 outside using the linearity property of Laplace, and we have Laplace transform of e power t. That's all. Now we are in a position to write the final answer, that will be e to the power minus s plus 1 Laplace transform of e to the power t. Using the formulas, using the basic formulas of Laplace transform, e to the power t has a Laplace transform 1 over s minus 1, right? It's a basic example. it's the most basic formula which we often use in Laplace transform, plus e to the power minus 2s, then Laplace transform of t, that is how much? 1 over s power 2. Again, this is a very basic formula. Laplace transform of t is equal to 1 over s square. Then Laplace transform of a constant, right? Laplace transform of a constant k is equal to k by s. So Laplace transform of 2 will be 2 by s minus e to the power 2, which is a constant, we have kept it outside. Laplace transform of e power t, that is again equal to 1 over s minus 1. So this is how you write a function in terms of unit step function, and then you apply the second shift property and you reach and you find the Laplace transform of that function. Okay, so I hope everything was clear in this video, and this is all for this one. We will meet again. I will come back with another topic in the next video. So that's all for today. All the best. Take care, all of you.